È un grande piacere avere qui per la serie dedicata alle accademie, le grandi accademie europee e il futuro dell'Europa, il presidente dell'Accademia finlandese Kimmo Kaski. We are very happy to have you here. Thank you very much. Professor Kaski is an expert of computational science at the Aalto University School. He is also fellow of the Wolfson College at Oxford University and member of the External Faculty Science Hub Vienna, and visiting fellow of the Alan Turing Institute, and many others memberships and awards. So he's a scientist who knows about humanism and about science, hard science. So thank you very much, and you can begin your speech. Grazie ancora per essere qui.
I have to apologize. My Italian is limited to a few words only, so I will speak in English during this presentation. First of all, I would like to thank Lincei Academy for this nice invitation to this nice setting, and I'm truly honored to give a presentation here in this setting and representing the Finnish Academy of Science and Letters. These two academies are rather similar in the sense that they have two departments, one department is humanistic sciences, and then the other one is natural and mathematical sciences. So in that sense, we are rather similar. Also, ladies and gentlemen, I would like to talk about the academies and the future of Europe, and the subtitle been focusing on knowledge-based decision-making. First of all, a few words about Finnish Academy of Science and Letters, which is, of course, a much younger academy than Lincei Academy. It was founded 1908 with the principal aim of promoting scientific research and acting as a bond between those engaged in advanced research. Our strategy stems on, our strategy is to make precious and valuable science. It stems on 4 pillars, I would say. First of all, impactful science, strengthen the influence of high-quality society or science in society, and then collaborative science, increase interaction and collaboration within scientific community, and also society as a whole. Then sustainable science, promotes sustainable development through science, and then progressive science, promote multidisciplinary and interdisciplinary science. It is an independent general science academy, and independence comes that it is financially independent. And it has an endowment of 200 million euros, and it owns its own premises in the center of Helsinki. That is rather unique, I would say, among the European science academies. They usually are somehow attached to the state or the government in one way or another. As I said, it has 2 departments. One is mathematics and natural sciences, and then humanities. It, like in tradition has been, publishes scientific publications, it organizes public events, presentations, discussions, and makes initiatives and statements concerning science and its practitioners. It also holds kind of new phenomena in Europe, this Young Science Academy, Finland. One of its key operations is indeed scientific advisory, which is to promote science-based decision-making. Here a few words about its governance. It is managed and represented by a board which consists of 9 full members. And here are some pictures about the board and then about the premises. The premises are just in a very short walking distance from the presidential palace, so we are in the center, very center indeed. Here's the multidisciplinary publication. It has published already from the very beginning. It was modified through the years, and then it was kind of reissued 2 years ago. And it is an open. Okay, I jumped. Wait, yeah. No. No. Okay. Yes. And then what I said earlier, it organizes public events of important issues which are going around. There are, first of all, one of the latest one, information and security, which is very much on the agenda these days, and a number of other things like energy and so on. As I said, there is the Young Science Academy. Its basic purpose is to promote science, especially from the perspective of young researchers in the early stages of their scientific career. And it's an independent operator, although we support it financially as well. So our motto of the Academy is for the benefit of science, for the good of society. And our logo has this owl, which is a kind of symbol of wisdom, or a very good eyesight as well, because it's a nocturnal animal like the lynx, which is the kind of symbol of Lincei Academy because of its sharp eyesight. Okay, talk about the science and decision making. The basic question there is how to bridge the gap between science and scientists and the decision making and decision makers. That's the key question here, indeed. Our Academy's goal is that the decision making at all levels of the society is done based on science and the knowledge it creates. So how we do that is by supporting researchers in effective and active social influence, bringing different actors together and build new cross-organizational connections between science, decision-making, and those that promote this kind of interaction. And also develop all the time operating models to support multi-voice interaction, networking, and partnerships. So about knowledge synthesis for decision-making, we have been very lucky, I must say, in terms of getting close to the government, although keeping our independence all the time. They have approached us for science advising and for helping their decision-making based on science. And with the government, we have been, first of all, developing all kinds of new operational models and piloting with the decision makers how this could go about. A few I pick up from the operating models, which I talk about a little bit more, is science panels, which is perhaps one of the more traditional approaches, and then phenomena maps, then scientific red teams, and also the impact training we do, especially towards the younger scientists. First of all, about the panel, we had this COVID-19 science panel, which is a multidisciplinary independent science panel appointed by the Prime Minister, but basically it was selected before that by the scientific community. So we had a lot of say. Those scientists in the board, in the panel, were 13 scientists representing different fields of science and research, public health, behavioral science, social policy, economics, education policy, resilience, and operational research. And it was indeed advising the State Secretary's high-level working group on prevention of social impacts of COVID. So it turned out in many ways successful, rapid response and commitment from the scientific community, indeed multidisciplinary, and we had a lot of say in forming that, and then effective use of the scientific network, key role in reopening schools. There was of course, challenges as well. Government's questions not always well framed. Some scientists struggled with translating their research to decision-making, and then communication of uncertainty, because in science there's always uncertainty element and new results coming up, so we have to be careful what we say to the politicians and decision makers. Then, of course, at one point, politics and power comes into picture, and then it turned out to be rather short-lived, and that was one of the challenge sides. At the same time, we had the Academy's own expert panel, which was focusing on understanding long-term consequences of the pandemic and strengthening the crisis resilience of the society. And it produced this document, Bending But Not Breaking, which I leave here for you to look. And now let's talk about next about the challenges of knowledge-based decision-making. Of course, through science, we have a huge amount of data being produced and information being produced. Problem is, indeed, that matching that knowledge created with the needs, and then the lack of informative overall picture. For that, we developed this phenomena maps, which is to be, which is to tell us what we know about the policy issue. It is basically a kind of systematic method for creating reliable evidence syntheses for decision making. The good points about it is that it's need-based and tailorable, possibility of combining broad overview, in-depth reviews, and evidence gap maps, and this flexible and transparent method ranges from systematic scientific literature reviews to horizon scanning, combining data and expert reviews. There was one of those was the quantum technology. There's a sizable quantum technology industry forming also in Finland, although it's a small country, but we do in a focused way. This phenomena map was based on the 12 Finnish scientists' informed view. Actually, it was 11 Finnish scientists and one Italian scientist as a professor at University of Helsinki, Sabrina Mariscalco, who is the quantum scientist at University of Helsinki as well. Okay. Then the other one was hydrogen in green transition. It was a view of 13 Finnish researchers. Then there was a Finland under change, summary information on effects of the war in Ukraine on Finnish society. That was based on interviews of 36 researchers from different universities in Finland and research institutes. It had 3 sections: multidisciplinary overview, thematic reviews on security, and then economic implications. Then, to go beyond this, is beyond just evidence synthesis, you need to think in different ways, and we have been developing this explorative dialogue-based space for scientists and policy drafters, kind of testing of early hypotheses in policy drafting by utilizing insights from scientists. There you have to take the starting point usually is that you have a question and then you try to find an answer. But then in these complex issues, you need to think the other way around. You use a kind of inverse logic, start from the hypothesis and claims and going from there. The method is as critical and co-creative review of draft documents by multidisciplinary scientific teams. Okay, the pilots with the government were the following. I don't go into detail in those. Then also we had these impact training courses, especially for younger scientists, how to approach decision makers. And because usually there's, as I said in the beginning, there's a gap, but this was to teach them what are the ways and how to approach to make an impact on policy making. So that training also produced a kind of handbook, researcher's handbook on science for policy, which I also read. Okay, and let's move on. The landscape is changing, and it's changing very rapidly. We need to take new creative approaches in order to be in step or in concordance with what is going on in the society. What is that change? The change is because of the information communication technology, which, as being digital, creates a lot of data, And that is a cause of this kind of data-driven or digital disruption. There was The Economist article 7 years ago, more or less, I think, it was titled "The World's Most Valuable Resource." And by that they meant data. Data is collected with a phenomenal speed all the time. And the big companies are collecting our data all the time. Whatever we do in the network, they are collecting it. So 80% of that data is in companies, or even more. I mean, 20% perhaps is in the public, kind of public hands, the health records, social records, and things of that sort. Here is the picture on the left down here, which shows that how fast the data has been accumulating. So the forecast was, I think that 7 years ago, that it would be by 2025, next year, it would be 175 zettabyte. Zettabyte is 10 to the 21 bytes, which is a huge, huge, huge amount. To describe how huge amount that would be, that is that if you use today's broadband communication technology, transferring that amount of data from place A to place B would take 450 million years. So it's a huge amount of data generated. Actually, that was a little bit under the current forecast. The current forecast is that next year there will be 182 zettabyte of data. So of course that data includes a lot of useful, but also useless and even harmful information. But to decipher that, we need to do data analysis in various ways. Here I have mentioned few ways to analyze that data. There's the data science, network science, AI, and the large language models. By those, we would get insight into human behavior, socioeconomic structure, society, and their functions, in good and bad, in both things. And of course, it affects all the things. These big companies, usually American companies, they are the titans of today. Of course, there is a strong battle between United States and China, who would get the supremacy in these matters. Let me talk about threats, because that's now has become more and more to the podium and discussions. About this science and technology, I would like to refer to what Nobel laureate Goodenough was saying some time ago about science and technology being morally neutral. It is how we use them that determines everything. We are seeing a lot of social bots. The social bots populate the technosocial systems nowadays. They are often benign or even useful, helping us, but some are created to harm us. by tampering with and manipulating and deceiving social media users. We see that a lot of all the time. Then the other thing, the threat thing, is the fake news. There was a study 6 years ago about how these true and false news spread in the social media and in the media in general. So the conclusion of that study was that the falsehood diffuses significantly farther away, faster, deeper, and more broadly than the truth in all categories of information. And the effects were more pronounced for false political news than for false news about terrorism, natural disasters, science, urban legends, or financial information. So in all this, to speed up the thing, artificial intelligence, AI, and the large language models, which came to the public notice just 1.5 years ago, have come into the picture in a big way. They also affect science making and science advising, or knowledge-based decision making for that. There are recent articles, I just take the titles here, about scientific discovery in the age of artificial intelligence. It was a Nature article, and then another comment article in the Nature as well. AI tools as science policy advisors. The potential and the pitfalls. And I take a quote from there: large language models and other artificial intelligence systems could be excellent at synthesizing scientific evidence for policymakers, but only with appropriate safeguards and humans in the loop. Why is that? There was another study made, which I picked up from the MIT Technology Review last year, where they had compared different large language models, how they perform in this kind of political map, being either libertarian or authoritarian scale, that's the vertical scale, or the left-wing or right-wing views. So even though most of these are American-based, you can see there is a spread how they would locate in the political map, this kind of political map. The reason is that these large language models are always biased because of the training set or the information fed into those. They're always biased because of that. And another fact of those is that they also hallucinate. They create something which is not true, which does not exist or could not exist. I had made a test asking this large language model to make a picture where there is a Tesla car, and in front of the Tesla car there was, I asked it to draw a nice horse stallion, beautiful Arabic horse. It created a very nice picture of a Tesla car, and in front of a very nice looking horse. But there was something wrong with the horse. the horse had 5 legs. So, I mean, it does hallucinate. Okay, so, I mean, we have to be cautious when using large language models. And then is, as this article in the advising, but also in science making says that we have to do it with appropriate safeguards and human in the loop. Because this title was Future of Europe, so I want to tell that we are not totally behind US in that regard. There has been this one project, EU-funded project for something like 5 years, which is actually run by the National Research Council, CNR, in Pisa. By those people, it's a European, tends to be European-wide, not totally pan-European yet, but I mean, it is towards that. And it's a European, now it's called a European Integrated Research Infrastructure for Big Data Analytics and Social Mining. I got these slides from, let's see, okay. Roberto Trassati, who is coordinator of this project. So there the idea is to use the big data to understand the complexity of society and offer services to researchers, industry, public bodies, and citizens through the creation of multidisciplinary scientific community according to the European vision of an ethical, legal, and open science. So it at least aims also to affect the policy makers, but it is not yet there. The countries involved are listed here, 14 countries so far, and the idea there is that there's an infrastructure, computational power, data set, methods, technologies, and so on. There's a research community where industries are involved, and then the ethical and legal aspects and open science to guidelines. And here are the kind of research space, different research spaces we are operating so far. And there are quite a number of researchers involved, a lot of publications being done, data sets in usage, and so on. So I basically want to end with taking quotes from the Martin Rees, who is an astronomer royal, and also a member of Lincei Academy. I checked that up. I'm a foreign member. He wrote recently, I think it was last year, book, If Science is to Save Us. And he's discussing about these grand challenge problems, various problems, these AI being one of them, and biology and food production and so on. It's a very useful read and a very insightful read. There he says that as a guideline to the scientists that scientists have an obligation to promote beneficial applications of their work in changing the world and shaping our lives, but also warn against the downsides. So this, when we're doing this advising for the policy and knowledge-based decision-making, we should remember that. politicians are not always that receiving in terms of saying these warnings or presenting uncertainties, which we should do anyway. He continues saying that, so if we are researchers seeking to understand the world as well as changing it, what are our responsibilities and how can we optimize that? We should ask the questions that how should we engage with the public and with the governments? How should we teach and inspire next generations? What changes are needed in the organizations where science is done? I mean, universities, research labs, and industries. So he ends up with the optimistic note anyway. If science is to save us, which surely it can, these are the questions we need to ask. And I also share his view in this, that it surely can, but we should make an effort. And I don't have these answers, but we should work together towards these answers. So the main title of the talk, Academies in the Future of Europe. Academies have one added feature. I mean, the scientists are usually trusted. In most parts of the world, they are trusted. They are always come in these surveys as trustworthy people. So academies, due to trust, have a definite role, in my view, in changing the world and shaping our lives. So with these words, I say grazie.